We have a set of laws called the gas laws that describe the behavior of gases. The first one that we will deal with and describe is Boyle's law. This is an important law. It can actually explain how you breathe with the contraction and the expansion of the lungs. And the reason why is because it deals with two parameters, volume and pressure. So if we begin and we read the statement, it says the volume of a fixed quantity of gas. So we have V, again, with a fixed quantity of gas. Remember, quantity always means the moles, which is N. So that's fixed means it's constant, it's not changing. At constant temperature, so also T is constant, here's the key word, inversely proportional to pressure. So what does that mean? It means if you keep N, the number of moles, the amount, constant along with T, as you increase the volume, the pressure will decrease, and the opposite is true as well. So as you decrease the volume, the pressure will increase. So that's what the word inversely proportional means. And you can feel that if you have you can really examine that if you have a balloon, and if you squeeze on that balloon, you know that as you're trying to decrease the volume of this balloon, you feel more tension, you feel that pressure. So what's happening in these diagrams is really close to realistically what's happening, which is if you see the molecules or the gas particles, they have a volume of about 1.4 liters. If you cut that in half, they have less space to roam around, and they end up actually striking the walls of the container and colliding with themselves. And again, that means that the pressure is increasing, building up. So you can see that half an ATM with 1.4 liters, the volume went down, and look at the pressure, it went up. So in this case, the pressure is low, the volume is high. Here we see that now the volume is low, but the pressure is high. And if you would like to look at it as a graph, you can see that as the volume, uh, here the volume is on the y-axis and the pressure is on the x-axis. As you can see that as you increase right here, as you increase the volume right here, so the volume right here is around 3, closer to 3. You can see that the pressure is small, it's about 0.25. As you actually decrease the volume, you can see that the pressure is going up. So look at 1.4 liters, look at the pressure, 0.5, look at 0.7 liters, it's 1. What they do sometimes is they actually graph it by the inverse, which means you put 1 over V, which would be directly proportional to pressure. So, you do the inverse. So what we need from this is really this equation. The equation is pressure times volume gives you a constant for, again, a given amount of gas at fixed temperature, as we said, and this is the equation that we need when we do calculations. The calculations are quite simple. They are plug-in problems. You just have to know what you're solving for. So you could be solving for pressure 1, volume 1, pressure 2, volume 2. And you just do a little bit of uh, mathematics, and then you get to the answer. So let's examine the first problem. It says here, That Freon 12 with this formula, CCl2F2, is used in refrigeration systems. What is the new volume in liters? So this is already asking you for the new volume. So new means 2. So in this case, we know that V2 is unknown. It's X. So this is V2. Of an 8-liter sample, so this must be volume 1. Again, liters means we have a volume. So make sure that you remember the units of those parameters. Volume is liters, pressure could be millimeters of Hg, atmospheres, uh, torr, uh, kilopascals, whatever. And we have, so let's continue. Freon initially, so this is the keyword initially, that means it is the pressure 1. 550 millimeters of Hg. After its pressure is changed to 2,200 millimeters of mercury. So we increased the pressure. So you can make a prediction about what's going to happen. So look at the pressure, look at what's happening with the pressure here. The pressure is increasing. It's going from 550 to 2,200. And if we go back to the law here that says that as you increase, let's say, the pressure, the volume, the pressure goes down, and the opposite is true. So here we're increasing the pressure, so we should expect the volume to go down. So going back to the problem, and we have everything listed nicely here. Let us write down the equation. P1 V1 equals P2 V2. What are we solving for? We're solving for V2 right here. So we're going to make this X. So we're going to say P1 V1 equals P2 X, which is V2. And in this case, how do we do that in math is we isolate X. So we divide each side by P2. So again, X, which is V2, let's write it down here so we won't forget, is P1 times V1 over P2. Now plug in P1, so it's 550. Plug in V1, which is 8 liters. And plug in P2, which is 2,200 millimeters of mercury. In terms of units, let's cancel out units. So the millimeters of Hg cancel out. And we would like to now just calculate this problem, calculate the answer here. And before we show you the answer, we write down the answer, we need to use sig figs here. So each number has 2 sig figs. This is 2 sig figs, 2 sig figs. So our answer should be 2 sig figs, and that would be rounded to 2.0 liters. So V2 in this case is 2.0 liters.